Okay, welcome to part 2 of the 2016 Unit 2 Technology Active Exam for Maths Methods. So the next question we're having a look at here is question 15. It's a probability question. So it tells us a pair of dice is rolled 5 times and the sum of their faces is recorded. The probability of it getting exactly 3 sevens is. So let's have a look at this. So let's go to CAS, let's start up a new calculator. So 3 sevens, we can get a 7 by doing a 1 and a 6. What else can we can have a 2 and a 5, we can have a 3 and a 4, we can have a 4 and a 3, we can have a 5 and a 2, we can have a 6 and a 1. So we could have 1, 2, 3, 4, 5, 6. So we can roll a 7 one of 6 ways. So that tells us the probability of a 7 equals 1 out of 6. So that's what we end up with there, and that's pretty cool always done that. Anyhow, so that's what we've got there. So then what we want, the probability of getting exactly 3 sevens. So exactly 3 sevens. So this is a binomial question. We can either have a 7 or we cannot have a 7. This is our probability of success. So we're rolling a dice 5 times. So we're going to roll the dice 5 times. So we have, that's our NC, so our binomial probability tells us PR of x equals 5 ends up being equal to NCR 5, 3, because we're rolling 5 times through 3. We're going to multiply that by 1 over 6. Hang on, we need to put that in the power. So 1 over 6 to the power of 3. 3, because that's how many successes we've got. And then we're going to multiply that by 5 over 6, because that's the probability of failure, to the power of 2. Now I'm just going to remove this part here, and I'm going to press enter. 125 over 388. Oh, that's a bit weird. Doesn't seem right. That's what we ended up with there. The probability of least. Okay, so that's what we've ended up with there. So we know it's not 7C3. We'll look at this thing with the 10. So what I'm going to do, now we've got either this one or we've got this one here. So we've got a 2 here, we've got a 4 here. We've already done it with a 2. So that's what, now we're going to check this NCR. So that's not, that number isn't any of these things. So we're going to do the NCR of 5 and 3. So NCR 5, 3, and we end up with 10. So it's got to be something with a 10, which is one of these two. They both got 3. This one's got 4 and a 2. We know it's going to be C for that one. So a bit of a roundabout way, but we got there in the end. Okay, question 16. Let's have a look. Graph of the circular function could be, so he wants to know what this circular function is. Okay, so we have a look at this thing. Is it going to be a cos or is it going to be a sine? So let's have a look at some stuff here. The first thing, we're told it's going up to 3. We're not told how far down it goes, but luckily 3 is the only option that we've got, so that's our amplitude. From there we can have a look and say, okay, for it to go from, we're looking at a cycle, we're looking at what our coefficient of x is going to be. So currently they are all a half, except for this one, which is 2x. So let's have a look at this. So we're starting off here at 0 and 3. We're going, and then that's one cycle there, but we don't have any information for it. What we do have information for is this. From here, we go up and around and then down. That's our cycle. That's there. So that tells us that if we're going from pi to 5 pi, that tells us that our cycle is 4 pi. So now if we know that t equals 2 pi on n, that's what we know our formula, t equals 2 pi on n. Well, if we've got a cycle of 4 pi, so we'd say 4 pi, so we're going to say 4 pi, that's our period, equals 2 pi over n. So that's what we're saying there. So that's what we're saying. Now all we do is we solve that thing for n. It tells us n's a half. Okay, so it's going to be one of these. Alright. Now, so the next thing is, well, what is it? Is it going to be a sine or is it going to be a cos? Well, if we have a look at it, we start our cycle here at the top, and we go this way, we go to the top again, and then we go a little bit extra. That type of graph is a cos graph. That's one cycle from here to here, it's just we've just given the people who have written the exam have just given you weird information. Ideally, they would give you this here being 4 pi, but that doesn't matter. So it's starting here and it's going there. You're actually getting more than a cycle. They're not telling you what the domain is, but they're showing you that it's going for more than a cycle. So what ends up happening here is you've got your cycle here, so it's a cos graph. Now, it starts at the top, so it's a positive cos graph. As a result, it's going to be C. Okay, which question is next? 17, I think, is that correct? Alright, let's have a look at 17. It's a graphing question from memory. Here we go. Okay, so a parabola is given by this equation. It's known that it has a stationary point at 1 and 3. It also passes through 3 and 7. The equation of the curve is... Okay, so I'm given this information and I'm given this information. So let's see, what are we going to do? A, B, and C. Okay, so stationary point there, that tells us we've got a turning point. So I'm going to write this in turning point form. So I'm going to say... I know for a parabola, turning point form is a x minus h all squared plus k. Now I am told that it's going through 1 and negative 3. So I'm going to set this to 1. That's what it ends up being, and I'm going to change this to negative 3. So that's what we've ended up with there. So that's what I'm just typing in there. Now I am also told that it passes through the point 3 and set negative 7. So if that's the information I've got, then I'm going to say solve. I'm going to take this and I'm going to let that equal negative 7. And instead of x, I'm going to put this in. This is where we're substituting our values of x and y. So I'm going to put this in here. And I'm going to change that to 3 because that's what we've got. So it's 3. Yeah, cool. And then I'm going to say we're going to solve this for a. I'm going to close that, and it tells me that, oh no, that's no good. Because there's a squared there. Okay, let's rewrite this. Yeah, this is no good. Oh, I didn't need this first bit. Okay, so this is just things that happen. Alright, so let's do this again. I'm going to go with this, except I'm going to take away this bracket. And I'm going to take away this bracket. I'm going to press enter. It's done it again. Why is it doing that? Oh, there you go. Alright, let's try this again. Incredibly frustrating. Don't want to be doing some exam pressure, but sometimes it's what happens. I'm going to take away this one, and I'm taking away this one there. So now let's see if it works. I'm going to take away this here, and I'm going to leave that as it is there. So let's press enter. Still giving me that. Alright, so we may have to do it manually. So with this is 3 minus 1, which is 4. So we're saying 3 minus 1, which is 2, squared, that makes it 4. So we're going to say 4a minus, 4 times a minus 3 equals negative 7. And I'm solving that. So a equals negative 1. Alright, so that then gives us negative 1 for a. So we're saying now we've got negative 1, negative 1, open bracket, x minus 1 all squared minus 3. So that's what I'm saying there, and there it puts it out for us. So x squared, negative x squared plus 2x minus 4, negative x squared plus 2x minus 4. That one there ends up being E. Maybe quicker to do by hand, but that's how you would do it on CAS. Okay, questions 18 and 20. Let's see if we get this done. Question 18. A graph of the function y equals f of x equals cos of x is transformed by a dilation factor of 3 from the y-axis, translation 2 units to negative direction of the x-axis, 1 unit in the positive direction of the y-axis, and then the equation of the image. Okay, alright, let's see. So we are so let's have a look. So positive direction of the y-axis. That's the first one I'm looking at. So okay, that's them going up by 1. They all go up. I don't know. These two go down 1, so it's not going to be those two. Now we're also told that it goes a factor of 3 from the y-axis. Now a factor of 3 from the y-axis, it tells us that we've got to have something in front of the x. We're going to have a third, because remember it's 1 over 3 for the y. We're going to have that in front of the x, in front of x. So it's not going to be that one. It's also not going to be this one, because that's 3. We want a third. So it ends up being that one there as C. So that's how we solve that one. We can graph it. We can look at dilating from 3 from the y-axis and the translation that in the negative direction, but that's just how we end up with it there. Okay, question number 20. Okay. Oh, this question was horrible. This one gave me a lot of grief as well. Alright, so we've got this thing here, y equals a 5b minus x. A is greater than 0, b is less than 0. Which of the ways of the following is true? Now, for this one, so let's see, we've got an exponential function. An exponential function does not have a vertical asymptote. It does have a horizontal asymptote, but that is controlled by the plus k, because remember, it's written in the form of y equals a times b to the power of x plus k. So that's what we end up with there. And if we want to be even more specific, minus h. And if we want to be even more specific, n. So we end up with that kind of thing there. So in this case, so it's not going to be that. The range of the function is y equals negative, y is less than a. So if a is greater than 0, then the range is not going to be less than 0. The range is going to be greater than 0, regardless of what it is. So if a is bigger than 0, the range is going to be y is going to be bigger than 0. So that's not going to be the case. So we're looking at either of these two. So the point 0, a over 5, a over 5 to the power of b, and for the interval b to a, function is decreasing. Now, I was really torn between these two, so let's see if we can do anything with this. So if I've got, now I'm going to rewrite that. I'm going to type it in exactly as it is here. So I'm going to say a times 5 to the power of b minus x. It's doing that. Why is it doing that? Don't know. Anyhow, let's see if we make b negative. Okay. Hasn't done anything. Okay, so let's say we're going to set, for this one, x coordinate is 0. We're going to end up with a y coordinate. So I am going to have this and turn this into 0, a to the power of 5b. That's a to the power of 5b. If I do a to the power of negative b, because it tells b is less than 0, we'll use our index laws. We know that ends up being a to the power of a times a. It ends up being that. As for this thing here, I'm not sure. My advice: try to graph it. A is a positive number, so we can set that as being 1 times 5 to the power of b minus x. So it's a negative number. We can try negative 1 minus x. And so we end up with that. So we can try to graph that. So I'm going to copy that. Just Control C, and I'm going to go to new graph. Hopefully it has copied it. Control V. I'm graphing that, so that's what we end up with there. And so between B and A, so we said that B, what we say B was 1, negative 1. So we said B is negative 1. I don't know. I don't like the wording in this question. I think it could be either of these, but I think it may actually be D, just mathematically, because if B, we make B negative, it just doesn't seem to work. I don't know. That's what I reckon with that one. I reckon it could be D, but check the answers and see. Hopefully someone else might be able to explain if I'm wrong. But that's it for the second part of the exam and multiple choice questions. We'll have a look at the short answer questions next.